All right. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover everything you need to know about FIPS 140-3, tailored for European time zones. Presented by wolfSSL Senior Software Engineer Kaleb Himes. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box, and after the presentation, Kaleb will answer any questions. As always, all of our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to reach out to us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DL178 support, a FIPS 140-3 certification and FIPS-ready offering, MQTT up to the V5 specification, SSH-v2, TPM 2.0, a secure bootloader known as wolfboot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full-service consulting. Now, I would like to turn it over to Kaleb to discuss everything you need to know about FIPS 140-3.
Thank you so much for the intro. And thank you, everyone who is joining us today. We appreciate, like we said in the beginning, your valuable time. So first of all, we're going to go over just kind of an overview of what is FIPS for anyone who may not be familiar with the program as a whole. So NIST is the government body in the US that was originally charged with coming up with a way of certifying cryptography as it was used in the federal space. NIST is a much older organization. They date all the way back to before the World Wars, where they used to govern things like farm machinery technology and oversight in that space. And then over time, they just grew and took on more responsibilities throughout the federal space, and ultimately culminating in what we are familiar with them for today with the FIPS body, and that's governing how cryptography is consumed and certified. And they kind of set the standards and then encourage all other federal organizations to abide by those standards. When NIST got this responsibility put on their plate, they realized that it was a lot. They didn't necessarily have the technical know-how to go and certify cryptography. They weren't familiar with the technology at the time, and this was kind of in the 80s and 90s time range. And so they set up a sub-organization called the CMVP. They hired some staff who began to specialize in learning what is cryptography, how do we certify it, what are the standards we're going to come up with. You know, the CMVP was given that responsibility. And so the CMVP is who writes all the special publications that we abide by today, like SP800-140Br1 for entropy sources, etc. The CMVP then realized this is a bigger workload than we originally anticipated. We're going to need a dedicated program just for testing the cryptographic algorithms, and then we will worry about the higher level things like, is the module ensuring its own integrity? Is it self-testing all the algorithms, etc. So they created a third body called the CAVP. And the CAVP tests algorithms. Oops, didn't mean to switch slides there. So the CAVP just tests the algorithms. The CMVP then focuses on the higher level things, and then NIST ultimately publishes the certificates. So that's kind of the ecosystem that we're dealing with when we're going through FIPS certification. There's also now third-party accredited labs that serve as the interface between the CAVP and the CMVP bodies and the vendors like wolfSSL Inc. who makes the cryptography. And so that's kind of what this slide here is showing is this is where wolfSSL Inc. resides in the ecosystem. We're a vendor. We make cryptography. We work with a third-party accredited FIPS lab to test our algorithms. Then they go off and contact the CAVP for vector certs. They pass them to us. We process them. They check the results and tell us if they passed or failed. Then we work with this lab to stress the module in every feasible way that will hit all the edge cases and ensure it's doing all the proper things and complying with all the FIPS requirements. Once the lab is satisfied and they deem the module to now be fully FIPS compliant, they'll submit a recommendation on our behalf to the CMVP that the CMVP issue us a certificate and consider the module FIPS certified. And then if they approve, we get added to the 140-2 or 140-3 module list, and we receive a certificate that gets published on the NIST website for all the public to then reference and say, okay, yep, wolfCrypt got their stuff certified. So just this is kind of a high level overview of the timelines that we're looking at in the transition between the 142 and the 143 programs. So FIPS 140-2 was highly specific to the US and Canada. They were the only ones really following the 140-2 standard. And then Europe and other national enterprises had a separate system called common criteria, which was very similar in some ways and then dissimilar in other ways. For example, a common criteria evaluation could leverage algorithm certificates from the US CAVP body, but then they had other test requirements once they got beyond the algorithm testing. So 140-3 is an attempt to essentially merge the common criteria and the US and Canadian standards, making them as nearly identical as possible, so that 140-3 will now be more internationally consumable, not only specific to the US and Canada. It could now work with some of our trade partners in Europe and beyond. And so the transition from 140-2 began in 2019. That was the first time 140-3 became effective, and we could start like testing modules against the new test requirements and working with labs to get our modules prepared for the transition from 140-2 to 140-3. Testing officially went live in September of 2020. September of 2021 is when our US and Canadian bodies finally said, okay, we're no longer going to be accepting 140-2 submissions. The only submissions we will accept from now on are things abiding by the 140-3, the new common criteria standard. And then September 21st of 2026 will be the end of date for all time for any 140-2 module. And that applies to even, as far as we've been made aware, units that have already been fielded and are 140-2 compliant. From what we've been told, it sounds like the federal government's going to ask that those units be recalled, updated to 140-3 and refielded. But for sure, no new federal contracts will be closable using an old 140-2 module after this date. Some of the benefits, the 140-3 program, I kind of talked about bullet 2 here already. Modernizes the standard, makes it more internationally consumable. Soon, they will be the only acceptable submissions. It'll be easier to stay up to date with the latest wolfSSL releases, as we've been doing FIPS now since 2014, so we're going on our 10th year, and we've really improved our way of managing things on the back end, making it much more seamless for our customers on the delivery side of things. And 140-3 has the latest and greatest of our efforts in there. That's why we say it's easier now to stay up to date. There are much stricter requirements and standards for 140-3, which translates to more assurances to the end stakeholders and customers. Hybrid modules and higher validation levels are now, I have the word possible here, but in reality, they were always possible. It's just much more challenging before. Under 140-3, now they've formally documented a lot of this stuff and improved the documentation around it. So it's much easier to realize a hybrid module certification and some of the higher level validations. Conditional algorithm self-testing is a new thing. So under the 140-2 program, we had to self-test all the algorithms immediately as soon as the module was powered on. With 140-3, it's now you only have to test an algorithm if it's actively being used. So for example, we had several customers that were doing data at rest. They were using bulk encryption and the SHA hashing algorithm, but they weren't signing and verifying anything. So they had no need for RSA, ECC, or Diffie-Hellman, even though those are available in our FIPS module. Yet they were still being forced to test RSA, Diffie-Hellman, and ECC every time they powered up their device, which could lead to slower boot up times. And now with the conditional algorithm self-testing, they never have to bother testing RSA, ECC, or Diffie-Hellman if they never use that algorithm. And the module handles all that for you seamlessly on the back end. If it'll check and see if a self-test is run, and if you go to use an algorithm that hasn't been self-tested, it'll automatically launch the test. Or you, as the developer and designer of your solution, you can preempt those tests at any stage that makes the most sense. So like if you have a down cycle where the CPU isn't doing a whole lot, that would be an ideal opportunity to go ahead and trigger the test while you're waiting for other things to spool up, for example. And then finally, processor algorithm acceleration was not, some PAA was not previously available in wolfCrypt FIPS, and we're bringing a lot of that into our module in the 140-3 program, specifically a lot of the ARM Thumb2 for ARM 32-bit processors, ARM Cortex-M assembly optimizations, Neon instructions, and then the ARM V8 architecture support as well. So next, we're going to go into kind of like FIPS here at wolfSSL specifically, now that we're kind of done with the broad overview. So when we're shipping releases, we often get asked, you know, hey, you did my certification work with wolfSSL version X, but you just shipped me a release for version Y. Can I use this new release you just sent me without risking invalidating the module? And the answer is yes. So the way we package all of our releases, the SSL and TLS library will update over time. So you might get 5.7.2. 3 months ago, you might get 5.7.4 today. And those are just changes happening at the TLS layer. The FIPS module that got certified is static and it never changes once it's certified. And we put a version of the certified module in all of our commercial FIPS releases. So you could run a diff on the module sources in the 5.7.2 TLS release and the 5.7.4 TLS release, and you'll see they're identical. The bullets on the left-hand side, I always kind of forget to cover completely. The graphic is kind of distracting for me, so I'll try to do better this presentation about covering these. So our solution is a lightweight crypto library. It's isolated from the TLS layer, like I just mentioned. Our TLS layer is, like was mentioned in the intro here, used to secure billions of connections today. It's portable, so we support many, many different operating environments, and we'll talk a little more about what comprises an operating environment and what that term means down below. It does matter for FIPS. We offer the full NSA 2.0 suite today, and soon, hopefully, we'll have the complete NSA Suite B, I believe is what they're calling it, with all the post-quantum stuff. So that's already being planned and starting to be worked on internally. Versions of wolfCrypt, like I mentioned in the commercial bundles, are all FIPS validated. And then we update the version of wolfSSL while maintaining the FIPS validated crypto boundary. So what, if you're familiar or have looked into our 140-2 solution, this slide is just covering kind of the deltas between our 140-2 and our 140-3 offering. And we'll be sharing this slide deck after the presentation. So if you want to go back and go over this in more detail, that'll be available to you. But just as a high level, we already talked about the CAS, this first bullet. We couldn't certify the key derivation functions previously. We were just certifying the algorithms that the key derivation functions consumed underneath. With 140-3, it's now possible to certify the whole KDF as a high-level algorithm itself. So we certified the TLS version 1.3 KDF, version 1.2 KDF, and our SSH protocol KDF. And that gets used with our wolfSSH product. We added testing for 3072 and 4096-bit RSA out of the gate. When we did our last 140-2 certificate, testing for these key sizes did become available about halfway through the life of our cert, but this time it was available from the very start. We added AES OFB mode in the latest certificate. We dropped support for triple DES, which the CMVP also invalidated on January 1st of this year, so it's no longer a FIPS approved algorithm anyways. And we anticipated that change was coming, so we dropped it early. And then finally, we now support a degraded mode of operation. And this is for some of our low Earth orbit customers. They had a requirement for this where if an algorithm were to fail its conditional algorithm self-test, and there was a backup algorithm that could do the same job, and the module could continue to function, they wanted that to be an option. So we did add support for that. And that's exactly what that is. Degraded mode is where if an algorithm fails its self-test due to a solar flare or something going off and flipping some bits in the processor, if it isn't correctly shielded, then you would be able to fall back to an alternate algorithm. And you can continue to fall back until you've exhausted all the options. And then at that point, they would have to do a remote restart of the system to get it back into approved mode of operation. This next slide is talking about our upcoming submission. So we have another submission already in process. We have certificate 4718, which has all the things from the last slide, and then our next submission will add all these new things as well. So AES cipher feedback mode in the 1, 8, and 128 modes. AES XTS, this will have both a streaming and a block encryption option, and it'll support the dual 128-bit keys and the dual 256-bit key offerings, which are called AES 256 and AES 512. We'll be bringing AES key wrapping into the module and certifying that. Password-based key derivation function 2, the SRTP KDF, so that customers using libsrtp can claim their key derivation function as FIPS validated. EdDSA is coming into the boundary, both 25519 and 448 curves, Shake 128, Shake 256. And then RSA, EastDSA, DSA are all being upgraded to FIPS 186-5 from the older 186-4 special publication. ARM V8 assembly optimizations will be available out of the gate in the new submission. And then we have our single multi-precision mask support in the submission as well, which is a highly tuned, highly performant, our most performant offering on most CPUs. These are the services that we are offering under the FIPS program as an organization. So anything highlighted in red is something that we don't offer, and anything in green is something we do offer. And this slide is trying to map essentially the old submission types under the 142 to the new submission type descriptions under 140-3. And it's just kind of showing all the same submission scenarios that we used to work on under 140-2 are still available under 140-3, even though they have a different identifier for the submission type. So things we do is we can add new algorithms to our module. This usually has to be combined with a update submission. But that's when, let's say, for example, I talked about how 4096-bit RSA wasn't available when we first did our 142 cert. It did become available about halfway through the life of that cert. And then any new OEs that we were testing after that point, we were combining with a algorithm and an update submission to make that 4096-bit RSA testing possible on all new OEs. And back then it was called, it was like a 1B sub or something like that. Or no, a 1A sub? No, that was a rebrand. Anyways, I apologize. It mapped to one of these old submission types, but now they've been separated out, and you just combine multiple scenarios to realize the same type of submission. We do OE additions. We don't typically do vendor affirmations or vendor affirmation updates. Although, actually, I could highlight this one in green. This does cover just administrative updates to the security policies, so I digress. That VUP we would do, VAOE we would typically not do. And that's just because we feel to do FIPS responsibly, you need to test everything. And we've had some customers report that this is not an acceptable approach in a lot of their federal programs anyways, so we don't really mess with it too much. We focus primarily on OE additions and actually testing everything through a FIPS lab. If anyone has any questions on any of these, I'm happy to answer them after. So I've been talking about an OE, OE up, OE addition a lot. So we do have this slide to cover exactly what is an OE. So when the CMVP is certifying an operational environment, they're not just certifying our module, they're certifying our module running on a specific operating system. And then all the math is being performed by a specific chipset. So this is what comprises an OE. It's the module plus the operating system plus the chipset. That's what gets certified. And if those details change, it either has to be reviewed and approved under a risk assessment by the federal procurement officer that is purchasing the module. So for example, if we certified this exact system and the federal procurement officer was purchasing a software product that used wolfCrypt inside, but they were going to be running it on Windows 11 Enterprise instead of Windows 10 Enterprise, that procurement officer could do a risk assessment on what are the differences between Windows 10 and 11. Do they anticipate that those changes will in any way affect the way the cryptography behaves? And if their determination is yes, it could affect it, then they would ask that you recertify a new OE that had these two details unmodified, but this upgraded to Windows 11 Enterprise. And that's exactly what we're offering as a service. For the most part, is we'll go ahead and retest that through a FIPS lab for you if your procurement officer that you're dealing with is demanding a new certification. And this term comes up a lot when you're speaking with your own potential FIPS customers or bidding on a contract or speaking with our support staff. We're often asked to help customers identify what they need to certify, especially if those customers are making like a software as a service and it might be deployed on any number of unknown CPUs or uncontrolled operating systems. It's maybe their software is very portable, just like our library is, and they don't control where it's going to be run. They'll often ask us, what do I certify? And our best advice is pick the most common system that you know your customers are using. Pick one of the most common, certify that. Just certify one because it's really expensive to do the certifications. So just pick one, certify that. Be very clear with your customers. Look, we tested on this system. It may be deployed on any number of other systems. If at some point you need us to certify an additional system, just let us know. We can work with wolfSSL to get that done. And then we do them on a case-by-case basis because, like I said, it's very expensive. So you don't want to try and certify 100 different potential operational environments all in one go. It just wouldn't be feasible. And then the other thing that's key here is, even though when we ultimately list, there's something called the tested configuration that goes on to the FIPS certificate, and we do have to list the form factor that we did the testing on. So we've had a couple customers that they might choose a laptop to use for the certification work, but then they've got a desktop that has the exact same operating system and the exact same chipset in it, and it's a different form factor. So just keep in mind, the CMVP is certifying the chip, the OS, and the module, not the form factor. We're just required to list the form factor we use for testing, and that's in the tested configuration on the FIPS certificate. It doesn't limit the FIPS validation to just the laptop design, as long as the OS and the chipset are the same. And then finally, on embedded, I mentioned we're a highly portable library. So we've certified, just about every embedded Linux flavor you can imagine. We've also certified real-time operating systems like OpenRTOS, FreeRTOS, ThreadX, NetOS Plus, proprietary operating systems that aren't even available commercially or open source. So yeah, we're really not limited by where we can run, I guess is the point there for embedded systems. This half of the slide is talking about what I just covered. This would be the form factor specificity. In the back before 2009, what used to go on the FIPS certificate was just the OS and the form factor used for testing. They didn't actually list the chipset here. Now, when we're doing the certification work, we have to list all three items as the tested configuration, and then just the operating system and just the chipset go into the security policy under the defined OE description and also onto the algorithm certificates. This half of the slide, we for a while there, it's not been as much lately, but for a while we were getting these questions about FIPS inside and FIPS canisters. We couldn't really find, so the CMVP acknowledges this term, but our best understanding of FIPS inside is that it's for when you're certifying, let's say, a computer system that has a motherboard, but then that same motherboard can be in 10 different models of a similar system. So a hardware vendor might choose to certify their motherboard, but they don't certify the 10 different product lines. And so they would say that's FIPS inside. The motherboard is inside the high-level design, so you can claim FIPS on all those 10 product designs that all have the same motherboard. I believe there was some software vendor out there trying to say that you could do the same type of argument with software, and as far as we can tell, that's not really legitimate. And the customers that did go with those solutions ultimately ended up coming back to us and saying, yeah, our federal program said that's not good enough. We need to actually do this for real. So I'll just leave that at that. For our OE edition, so we used to call these a 1 sub. Now we call them an OE up. This is the primary FIPS service that we're offering, and this is the outline of how that process looks and all the work items that we go through to accomplish it. And they're separated out by major milestones. So when we engage with a customer that needs FIPS, we'll ask them to send us their hardware, software, accessories, core, and accessories might be like a JTAG debugger if it's embedded, if it's a server system, that would just be the power cords, etc. We ask for a simple guide. How would you in your production, when you're making your software tools or whatever it is you're doing, how would you compile and flash an executable onto the target you need us to certify? And you can replace, whatever your proprietary stuff is with just a simple hello world program. All we need is the process for compiling, flashing, and running an executable on the target. And then we'll stand up wolfSSL and wolfCrypt for you. If you do that on your own in advance, it does speed up our effort, but it's totally not necessary. That's part of our service. And then we'll take that through certification with the lab, culminating in algorithm certificates at the end of milestone 1. So those will get published on the CMVP website. In parallel to phase 1, we'll also be working on phase 2, which is doing the operational testing with the FIPS lab and reviewing that the module is compliant on that specific system with all the original criteria that we had for the original submission we did that gave us the cert to begin with. Once the lab is happy, they'll go ahead and submit it to the CMVP, and that's what marks the end of milestone 2. And then the CMVP will review, and they'll either ask us to fix something or address something, or they'll just approve depending on the quality of our test report. And then they'll update our FIPS certificate saying, okay, we, the CMVP, now back the claim that when this module is run on this chip and this operating system, it is fully FIPS certified. And that once the certificate updates on the NIST website with that information, that is the end of the effort and milestone 3. Products and services that benefit from our FIPS module is the next topic. So we have a bunch of internal stuff that we do that benefit from this, and also some third-party external stuff. The first one is our Linux kernel module. So we have a crypto kernel module that can offer FIPS validated cryptography at the kernel level and take the place of default crypto kernel modules. We've tested it a lot on ARM and MIPS, and we have also certified on Windows CE in the kernel space with our Windows kernel module. And yeah, I guess that's kind of that for this slide, but if there's any questions on that, let me know afterwards. Other products of ours are the SSL and TLS stack. Obviously, the crypto module is a sub-element of the SSH product that we offer, our MQTT client, our Wolf boot, secure bootloader, our JNI JSSE provider for Java, and our JCE provider for Java, and then all of our language wrappers, Python, C#, etc., obviously would benefit from consuming FIPS certified crypto. And then the third-party solutions that we are knowledgeable that customers are using us, our FIPS certified module in, are Nginx, WPA Supplicant, Strong Swan, OpenSSH, where they aren't using our wolfSSH, but OpenSSH can consume our crypto module, Apache, S-Tunnel, Lighty, and then the largest benefactor, OpenSSL. So OpenSSL had they had let their FIPS certification expire a couple years back, and we were able to fill the gap for a bunch of customers. We stood up our own engine for OpenSSL 1.0 and 1.1, where you could register our FIPS certified module as an external third-party engine with OpenSSL, and then anything consuming OpenSSL on the system and needing cryptography would reroute down to our module instead of using the OpenSSL default crypto. And we did the same for OpenSSL 3.0 Plus. They just changed the name from engine to provider. And so we have both a Wolf engine and Wolf provider offering to fill that gap where either you don't have access to the OpenSSL FIPS module, or OpenSSL has let the FIPS certificate lapse and go onto the historical list without refreshing it. And then lastly, where we at in the 140-3, or what's our status under the 143 program. So I've mentioned it a few times, but we got our 143 cert on July 11th of 2024. It's FIPS certificate 4718. Just some notes about the IoT and embedded systems. So we have an in-house test rig that we've developed that will allow us to process algorithms on embedded targets that don't even support a file system. So we use a full duplex serial connection or Ethernet connection to get vectors onto the target, process them on the target to be certified, and then we send the responses back to a host computer, which then formats the file for returning it to the labs, and then they upload it to the ACVTS server for confirming whether or not the device processed the stuff correctly. We were the first organization in the world to complete the new 140Br1 automated CMVP submission, which we were very proud of. So we worked with a lab, Aegisolve Incorporated, to accomplish that. And that was pretty neat because we were involved in the pilot program, and it was something that nobody else had done yet. So we're quite proud of that. As far as upcoming stuff, I already talked about it in several slides back in our overview section, but this is just reiterating the same stuff. So we've got a submission in process that's going to add all this to our next certificate. And then on our current certificate, we've got 25 OEs. We're weeks away from submitting those. Right now, we're just waiting on the lab. We've completed all the testing on all 25, and we're waiting on the lab to finish their reviews. And then the CMVP made some sort of change to how the OEUP submissions will happen. So the lab's also having to adjust for those changes, which we were ready to submit around October 4th, I believe, was our original submission date. But then with the CMVP changes coming down the pipe, our lab said that put them back at least 3 to 4 weeks at a minimum. So however long it takes them to come up to speed on the changes and then finish the reviews of all the test results that we did with them, these will get submitted as soon as possible. So they're ready to go. We've already started work on the next batch of 30. We're getting the documentation in order now, and we'll begin testing the next 30 OEs that we're going to add here shortly. And we've got even more OEs coming in, or more purchase orders for additional OEs to be added. And so we've started the batch 3 queue now, and it'll likely, as soon as we submit this one, more than likely we'll just start testing the third batch, however many happen to be in that batch. So I guess my only point there is, if you need one soon, let us know before that third batch fills up. We tend to cap them at a reasonable number for what we think we can accomplish. The first batch was 25, the second was 30. So yeah, we'll cap it wherever we end up. when the time comes. And then that concludes our presentation. So if there are any questions at this point, I would open it up to that.
Thank you, Caleb. Can you advise what is the NSA?
The National Security Agency.
Perfect, thank you. And roughly how long does the certification take?
It depends. So I can give estimates for the 140-2 programs. For 140-3, we don't really know yet because as far as we know, we're going to be one of the first ones who does one of these revalidation scenarios under the new 143 program. I don't know that anyone else has done one yet. So under the old 140-2 program, it used to take about 2 months to get through all the testing with our lab and then for our lab to submit to the CMVP. And then the CMVP could review and approve things, usually in about 2 weeks. And that lasted, that was a pretty steady cadence up until 2020 and 2021 hit. And then after the pandemic, things slowed way down there for a while. The CMVP lost a bunch of staff, plus they were all working remotely, so they had to retrain. And things really stretched out. It went from, 2.5 to 3 months to now it was taking us 4 to 6 months to get through the whole process. Then that lasted up through the end of 2023. And we submitted an OE edition in January of 2024, and it got approved in just 24 hours. So we did all the testing with our lab, took about a month and a half, and then we submitted it to the CMVP, and it was approved in 24 hours. So we don't really know what things are going to look like yet under 140-3, but I'm assuming it's somewhere in that 6-month range is a safe bet. And then anything less than that would just be a good surprise or a happy outcome. So yeah, definitely plan half a year out is what I would say at a minimum.
Perfect. How do we know that a certain product needs to be FIPS certified? And is there some document that specifies when a product needs that certification?
Yeah, so it'll be the federal program. So I don't deal directly on federal contracts, but we have worked with a lot of people that do. And my understanding of the process is the federal government or a federal body will put out a request that says, we need a solution for this. And it'll define, like, let's say it's I'm using a past example, an M1 Abram tank, and they have a requirement for an engine controller unit that needs to perform certain tasks in the engine. And so then multiple customers will bid. They'll say, we can develop that engine controller unit, and this is what we think it'll take us. And then whoever ends up winning the bid or winning the contract, they'll get the contract specifics after they win, and that's when it'll say it has to be compliant with FIPS 140-3 level X. And then that's when they will know for sure there's a FIPS requirement, and that to finish this contract, they'll work with some entity, and we are one of those options to work with.
Perfect. Can we move to 140-3, but Windows 2022 is still not FIPS certified?
No. So we have Windows 10 and 11, I think, in process, or maybe it's just 11. I don't remember. But no, I haven't seen any of the Windows servers come through in an order yet.
Can you give a rough ballpark kind of on pricing?
I don't think that I could. I'd have to defer to one of our sales reps. I don't track our pricing, and it may change over time. So I'm just an engineer. I apologize. I can't give price estimates.
All good. You mentioned that MLDSA will be available soon. Is it weeks, months?
So MLDSA is already available in our library for testing and prototyping with. As far as when we submit it to the CMVP, I'm not sure when that will become an option. I know the CAVP is now offering algorithm tests for it, so we could test against the demo server. But I think there's still some work before you can actually get it certified through the CMVP, and I'm not sure at this point when that will become available. I do know we attended the White House briefing that announced they had the publications ready, but even though the publications are out now, the CMVP still has to stand up the test requirements for them and finalize all that.
Perfect. Sorry.
Oh, sorry. I was just going to say, if I had to guess, my best guess would be it'll be available in sometime in the next 2 years. As soon as it's available, we will absolutely begin work on a submission to support it.
Amazing. Do we need to recertify an OE when we apply CVEs to a Linux distribution like, oh gosh, I might butcher this, Ubuntu 24?
Ubuntu 2024.
Yes.
Yeah, so, obviously, knock on wood, we've never had a CVE come up in the module itself to date, thankfully. But if we were to do a CVE fix, yes, we do try to retain all the hardware. And we've communicated this to several customers now that ask for their hardware back after the testing effort. We just let them know, if a CVE comes up, we're going to have to ask you to ship it back so we can retest with the CVE patch in place. And they've all said, yeah, that's fine. Just let us know. So.
Fabulous. If a chip has an on-chip crypto hardware unit accelerator that says FIPS CAVP, not CMVP certified, what does that mean for a product that uses the chip? And does it make it easier to get FIPS 140-3 certification if we use the hardware accelerator, or rather we should use software-based implementations?
That's a fantastic question. So if it says CAVP certified but not CMVP, all it means is that the algorithms they've been tested, they are doing everything correctly. Nothing has been reviewed by a FIPS lab for the other FIPS requirements. And the other requirements would be things like, is it doing a conditional algorithm self-test? Is it doing an integrity check on itself? Can it detect tampering? Is it zeroizing all the critical security parameters correctly, et cetera, et cetera. So there's a bunch of requirements beyond CAVP, and that's what the CMVP itself does. So if it just says CAVP, it means that the algorithms run right, but nothing else is being done for the FIPS compliance, or if it is being done, it hasn't been reviewed and certified.
Thank you. Do you help with certification for an OE with public clouds like AWS or Azure?
Yes, we do. So we've actually talked to our lab about the CMVP put out a announcement, I believe it was in November of 23, that said they would now allow remote operational testing for cloud environments only. But if it was not a cloud environment, we still were under the obligation to have the physical hardware on premises as we were doing the certification work. And just so I don't miss it, on the last question, was there an additional part at the end of that question? I know I answered the thing about the CAVP stamp, but was there something else?
It was, does it make it easier to get a FIPS 140-3 certification if we use a hardware accelerator, or rather we should use software-based implementations?
Got it. Okay. So CAVP, I would not say it makes it easier. And the reason I say that is because we recently were talking to a customer about the ATECC 508A, which is a sub-chip component that is offered by Microchip, if I'm not mistaken. It was originally by Atmel, but then I think Microchip acquired Atmel. And we were trying to figure out how they did their CAVP testing because the ATECC has a feature where once you put key material in it, you can't get it back out. It basically becomes a black hole. You put key material in it, you can never access it again. And in order to complete CAVP testing, you have to generate key material and then return that key material to the CAVP to review it. So we were like, how did they do CAVP testing if once the key material is in the thing, you can't get it back out? So we contacted Microchip. We were talking to one of our contacts there, and he said they were actually using wafer boards to test in their labs, but the actual end product you wouldn't be able to do it with because of that feature where you can't get the key material back out. And so we asked them, well, are you going to do full CMVP certification? And they said no, because the wafer cards, while we can CAVP test them, you have to use the end product in CMVP testing. And because of the design, we can't actually do it. And that kind of left us stumped. So I would say CAVP does not in all cases make it easier to achieve CMVP. Now, the flip side of that is if you've done CAVP and you can complete CMVP and the hardware design supports it, then yes, it would make it easier. I hope that covers all the bases.
I think it does. Is there a list of hardware platforms that you are targeting for FIPS 140-3 compliance with the SSL solution?
Yeah, actually, so one of our marketing staff yesterday was working on publishing on our FIPS landing page a list of all the platforms that we have in process. Let me see. I know it was, she had the template up, but I don't know if it went to publish yet. So let me go check real quick. Yeah, they're not up there yet, but they will be eventually, and I'll put this in the chat here. They will soon, within probably the next, I don't know, 2 or 3 days, they will be on that website. I just put the link in the chat too. And some of the details will be redacted at present, so we never publish anything publicly unless the customer specifically requests it, but we never publish it publicly before it's on the FIPS certificate. So once the table does go onto that web page, like I said, a bunch of them will read like redacted at the moment, but there will be enough detail there to tell what the operating system is and what the CPU design is. And then the other details will be made public once the certificate is updated.
Perfect. The questions keep rolling in, so we're going to keep going.
Cool.
Do you also work on helping with certification of Strong Swan, or can it depend on wolfSSL for all its crypto functions?
So Strong Swan is a higher level application that consumes cryptography. If someone needed the entirety of Strong Swan to be certified, yes, we would gladly work with you to accomplish that. But the only time I would see that being required is if you were doing like commercial solutions for classified or something and certifying the whole system where every application consuming cryptography also had to be reviewed. But yeah, most use cases that we're seeing with Strong Swan are the latter in that question, where Strong Swan is just relying on wolfCrypt for all of its cryptography, and then we just certify wolfCrypt.
Thank you. wolfSSL already supports secure elements from FIPS validation perspective. What is the more advantageous to use secure elements versus on-chip crypto modules versus software-only solutions?
I'd say the biggest benefits for using secure components like a trusted execution environment or a trusted private module or something like that, is when there's some sort of requirement in the contract that the key material be stored in a compartmented, isolated location, separate from flash memory. And then if that requirement is not in whatever federal contract is being bid or worked on, that's when I would say just a software solution is sufficient. And some examples might be like, we've got federal customers with FIPS requirements, and the only thing driving that FIPS requirement is that they have to upload reports to a server in Washington, D.C. And in order to connect to that server, you have to be using FIPS compliant cryptography. But the reports they're sending are like all public data or something that they don't care if it's leaked. One example would be the Fish, Wildlife, and Parks, doing reports on numbers of trees in a given region or numbers of wildlife in a given region. They aren't going to care as much about where the key material is being stored, et cetera, as say a nuclear submarine would, or a computer system on a nuclear submarine would. I hope that kind of helps.
Yeah. Could you please clarify the self-test on only the used algorithms and running those when the CPU is not busy?
Could you read that question again? I'm sorry.
No, you're all good. Can you please clarify the self-test on only the used algorithms and running those when the CPU is not busy?
Yeah, I will try to clarify that a bit more. So before under 140-2, we had to run them as the device was powering on. So that's like as all the initialization is happening, the threading is being stood up, maybe the entropy pool is being initialized for the first time, yada, yada. So that's kind of like what I would consider a downtime as the program is coming online. So before, we used to run them in the attribute constructor space, which is before main begins to execute. Now that would be, since they're optional and you can control them, I would say the downtime would be immediately after main begins to execute. That would be like an ideal time. It's still kind of like doing it during the power on cycle. It's just slightly later in the process. Another option would be, we have a customer that's doing stuff on an Android phone, and when the app goes to sleep, that's when they're running the cast. So like a user opens the app, they do some stuff, and maybe they don't need a TLS connection right away, and then they click the little button on the side of their phone that puts the phone to sleep. That's when they detect that state, the phone is now sleeping, and they run all the casts right then. That way, the next time the user wakes up the phone and the app comes back to life and they go to do a TLS connection, it's very quick instead of suffering the downtime of running those casts as the TLS connection is being established.
Perfect. Last two questions here. You mentioned MLDSA to be available for testing and experimenting as of now, with a potentially certified implementation available in a 2-year timeline. Any idea when MLDSA and MLKEM will be considered ready for production, even without being fully certified?
Oh, that is a good question. I believe they're already there. I believe we would consider them production ready at this point, MLChem and MLDSA, both.
Perfect. Are entropy validations included in the certification?
Oh, hang on one second.
Oh,
I
sorry.
apologize.
No, you're all good.
Oh, my calendar's yelling at me in my headphones, so it's drowning you out. Okay, it's done. Go ahead.
Are entropy validations included in the certification?
No, so the CMVP has separated all entropy validations from FIPS validations. So we are doing our own software-based SP800-90B compliant entropy source. We just call it wolf entropy or MEMUse entropy. And we'll certify that under the ESV or entropy source validation body, which is separate from the CMVP at this point. They've been split apart. So we can offer those, absolutely, but they happen separate and under a separate program.
Perfect. Well, thank you, Caleb, for hosting an informative webinar. Thanks to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions at all, don't hesitate to shoot us an email at facts@wolfSSL.com. We're here to help. Thanks again, and we look forward to seeing you next week on November 6th for Ensuring Security in Avionics with DO178C Conformance. Thank you all.